Good afternoon, everyone, and welcome back to Tech Talk Tuesday here at Treadwell. Couple of things. Firstly, I would typically use my name. If you've joined before, welcome back. And if you're joining for the first time, welcome. We hold these brief 15-minute sessions, typically bi-weekly on a Tuesday, sometimes a different day, but typically on a Tuesday. We run over a variety of topics related to FRP, design standards, sort of environments we work, all that sort of stuff. Now, today's is the lucky last session for 2025. So thank you very much. Hopefully we can go out with a bang. And our next session will be most likely on Tuesday, the 3rd of February, 2026. So that year's gone unbelievably fast. But anyway, without any further ado, we'll get started. So today we're looking at grating fixings, specifically different fixing methods. So we won't review every single fixing type, but we will look at the two fixing methods that we typically use or recommend, and where each method is suitable, where it's not, some advantages, things to think about during design, all that sort of stuff. So having said that, we'll have a Q&A session at the end, but I've got the Q&A window open in front of me now. So if you think of anything as we go along, just feel free to whack it in the Q&A window and we'll address it as we go if we can, or we'll deal with it at the end. And usual housekeeping stuff. This is general advice, not site specific. If you'd like a site specific discussion, reach out. Happy to have a chat and catch up with anything you might like to discuss separate to this session. So, grating fixings, why does it matter? Obviously, we need to fix down our grating. We're talking about really in the context of FRP grating today, but it would apply to a lot of decking products or walking surfaces. So, two main fixing types that those two fixing types that are used are what we will refer to for the purpose of this discussion as direct fix. So that's secured directly to the support structure, whether that's FRP, steel, timber, aluminium, HDPE, wood, plastic, composite, there's a whatever it might be. So that would be either bolting or screwing directly to the support structure, and a clamp-based fixing method, which uses a clip on top, a component underneath that will clamp the grating product to the structure without any drilling required. So they're the two methods that we would use. Direct fix is pretty straightforward. We use a screw or a bolt. Now, a couple of things to think about. Typically, and this first point considers bolts, if you're using a screw, clearly you don't need access underneath. But if you're using a bolt and nut, you will need access underneath the structure to install, and also to remove if you want to take it off for any inspections, maintenance, or anything like that. You'll need drilling of the support structure in any case, whether that's a screw or a drilling a hole to put a bolt through, which will damage your protective coatings and generally lowering cost than a clamp arrangement. There's less components, so it's going to be lowering cost. Where this is typically used, if our support structure is timber, we'd screw to it generally. If it's FRP, we'd screw or bolt with a nylon lock nut, depending on the details of that structure, any vibration, that sort of thing. We might screw through a light gauge steel structure with a self driller or self tapper. And if we're using an aluminium structure, we might also screw into it or bolt through it. And if we're using some sort of other plastic profile like poly, HDPE, a WPC, or wood plastic composite material, something like that, then we would obviously screw to that structure. So, in short, where it's acceptable to put something through the structure, whether it be a screw or a bolt, uh, that this is a good method. And some materials like timber and so on, there's no need, or FRP, there's no need to be using a clamp arrangement because drilling a hole in that material is not a problem. Didn't mention it here, but where we're using especially a screw, I didn't mention it here, and I did mean to put it in, so apologies. We'll just discuss it verbally. When we're using a screw, sometimes there's issues with vibration and fixing loosening. There's a couple of ways to deal with that. One is a very thin rubber sheet, maybe 2 or 3 mil, between the bottom of the grating and the top of the support structure. So it would sit between the bottom of the decking product and the top of the support structure. Or we use a nylon washer under the head of the screw. Both these methods appear to keep a little bit of tension on the fixing, and they do seem to reduce that issue of screws backing themselves out. If we use a nut and bolt, we'd use a lock nut, a nylon nut, as standard. That helps deal with any of those sort of maintenance issues. But it's important to note, if you're expecting you may need to remove grating, you'll need access underneath to remove it. You'll obviously need access below to install if you need to put a nut underneath the structure, but you also need access underneath to remove the structure, to remove the grating, I should say. So just keep that in mind if you expect something to need to be removed on a semi-regular or potentially removed basis. Now, clamp-based fix, we've mentioned that also. This is the other method we commonly see used. Now, how this works is, as we've probably seen, there's a clip on top and another piece underneath that will clamp to the leg of a channel or the flange of a UB or UC or something like that. Now, we'll look a little bit later on at what those fixings look like, but a couple of things to think about. The clip strength must be appropriate for the application, so not all clips suit a higher uplift force. That might be due to wave action or vibration if we're installing a grating product on, say, a ball mill or a sag mill or some sort of vibrating or rotating plant or equipment where we expect to see some vibrations in that structure. Not all clips are suitable for that. And we'll come back to the second to last point shortly, but then the last one, firstly, is not generally recommended for stair treads, and we'll have a look at why that's the case a bit later on in this presentation and what we can do to make that workable for stair treads. Now, one thing we often see overlooked is the fact that if we want to do a clamp arrangement, and we often do, because if we've got an FRP structure, we don't mind. If we've got a steel structure that we've got hot dip galvanized, or we've got a coating on, or something like that, we obviously don't want to drill any holes in that structure and damage the coating. That would defeat the purpose of the coating. So we want to clamp to it. But it's a bit more difficult if we haven't thought about that during the design phase, because we obviously need the leg of a channel or a PFC or an angle, or we need the flange of an I-beam or a UC, UB profile, whatever you want to call it, something like that to clamp our grating to. If we use RHS or SHS structures, a bit of a challenge. We can fix that by welding on some little tabs or cleats horizontally, so in plane or perpendicular, or I should say parallel with the grating or the decking, the walking surface, and that can allow that clamp to be done. Or we can cut a hole in, for want of a better term, one of the webs of the square hollow section, and allow the clamp to pass through and clamp onto the underside of the flange at the top of the square hollow section. I don't know if this is making sense, because we should have done a little illustration. But something to think about is around bearing area. If we put a channel in the middle of a walkway and want to clip both sides to it, that's problematic. We can put a UB or UC in and clamp both sides. However, and not to divert this, but we'd require some bearing area on a specific bearing area, or minimum bearing area, I should say, to support both edges of that grating and make sure it's supported adequately. Typically, a minimum bearing area we'd recommend is 40 mil, or if a product's thicker than that, the thickness of the product, so 50 mil mesh, 50 mil thickness, typically 50 mil bearing area, and so on. I don't want to derail this, but just something to think about. Where to use clamp fixings? Obviously, if we've got a heavy gauge steel structure, we may not be able to drill through it, or use a self-drilling screw or something like that. But normally we want to, if we've got a galvanized or coated structure where damage to a coating is not acceptable. Most suited to open section structures, which we've just touched on. So by open sections, we mean PFC, UB, UC, equal angle, those sort of profiles. However, if we want to use some closed sections, so RHS, SHS, we can weld on some little tabs or cleats. or we can cut a hole in the web, as I mentioned, to allow the clamp to engage with the underside of the top flange, if that makes sense. So just a summary then, applications of direct fixing, FRP, timber and other non-metallic structures are common uses for these. If we're using a bolt and nut, access is required underneath for installation and removal. If we're using a screw, then obviously that's not the case. Clamp-based fixings, if we're using especially heavy gauge steel structures or structures with high grade coatings, good option. Resolves dissimilar metals issues, and you might remember if you joined us before, we did a session on dissimilar metals back a few months. Feel free to look that up. It's on our YouTube channel or on our website. We'll just touch on that on the next slide very briefly around that. But in a lot of cases, our clients like to use a stainless fixing. It lasts a lot longer, especially when we typically get a bit of build up on the top of the fixing. It looks a lot more aesthetically pleasing, but we can cause ourselves some issues if we've got, say, a mild steel structure that's hot tip gal underneath, and we don't want the stainless and the gal in contact. We'll create ourselves some challenges with dissimilar metals. And lucky last, excuse me, in some cases, access underneath is required for installation, however, not generally required for removal. So when we're installing something, we may need access underneath in some cases. In other cases, some fixings are able to be inserted entirely from the top. However, we are able to loosen that fixing from the top, and so we should be able to remove it without having to get access underneath, whether that's scaffolding, EWP, boats for structures over water, something like that. So a bit of an easier option there. Now, dissimilar metals. As I said, we mentioned this in a session previously, but we'll just touch on it in relation to grating fixings today. Often we can see dissimilar metals concerns that are brought about by grating fixings. For aesthetic reasons, obviously, stainless is often desirable, and for durability reasons as well. However, that's not going to play nicely with this mild steel structure. So we've designed a clamping arrangement where there's both our J clip and H clip, and we'll look at those shortly as what they look like, with a custom injection molded poly or nylon insulator that fits around the clamp. And here's a rendering of one of those. And that means that there's no contact between the stainless surface of the underside clamp and the actual structure itself. So that's isolated by this nylon or poly insulating pad, for want of a better term, and that deals with our fixing concerns. So we've got stainless fixings, no worries, nice and durable and aesthetically pleasing. We've got our mild steel structure, or our structure with a coating on it, or whatever we're using, and then we've got the contact between those items isolated with the use of this pad or isolating piece that sits in between the clamp and the structure. So no damage or scratches to our coatings, and no contact with the galvanized structure, or no contact between stainless and mild steel from a galvanic corrosion perspective. Now, just very briefly, I'm not going to read the catalogs to you because I'm sure everyone's able to do that, but you can access all these items on our website under Resource Center, and also in the tread spec calculators you can make fixing selections. But these are what we call a top clip accessories. So standard and mini mesh M clips, so 1, 2, and 3. A C clip, which is used to join two sheets together on an unsupported edge. An L clip supporting a fixing down where we have a surface of a structure adjacent to the grating product. D and E clips for interlocking somewhat to provide a bit of lateral restraint to a grating product. W clip as a disc style fixing that sits on top of the surface. S clip that sits semi-flush with a solid product, and O clip which is recessed into a solid product tray, completely smooth surface and no trip hazards. And then underside accessories. So we talk about underside clamps. We've got a variety of options here. We have our mini and universal J clips, so they suit different mesh opening sizes. They're available with an insulator. We have a H clip, which is a heavier duty style underside clamping arrangement, generally used for wave uplift zones and those sort of things. However, good option. It has a thread tapped into it, so you don't need to be installing a nut underneath. Once you've put the clamp or the bottom part of the fixing in place. Also, an insulator available for the H clip. A G clip, different profile, typically used for fixing over some thicker structural members. No insulator typically available for that because we need a good engagement or a good friction with the member. U clip, once again, clamping down to a member, typically used where the bottom of a member is, or the surface we can clamp to is a little bit further away. We don't need to get any engagement with the grating. It's the underside of the grating for that clip, whereas the J and H and so on, you can see this little tab that sticks up. We need that to engage with the underside of the mesh to stop that rotating. V clip can be used in conjunction with an M or W clip, top style clip, to join two adjacent sheets together to one another to prevent any differential deflection. And then lucky last is the T clip, and this is designed for the square mesh products, so 38 and 50 mil openings. And this can be inserted from the top of the product, so we don't need any access underneath. Now, we're getting towards the end of this, so thanks for your patience. We are over time. But just before we finish, and excuse my very low quality drawing here, but I hope it'll display the point. We don't typically recommend clamping arrangements for stair treads. Now, why is that? The reason for that is if we have stair treads, especially where we've got a stringer that might be toes outwards, if that makes sense. So we're mounting to the inside web of the channel, and we're clamping to a ledger bracket or a bit of flat bar that's welded onto the channel or something like that. If that's the case, and these fixings were to loosen, then there's no longitudinal restraint on the stair tread, which means if the fixing is loose and someone runs down the stairs, that tread could slide off this ledger angle here, and that's obviously problematic. We've got no tread, trip hazard, someone could fall through, that sort of stuff. Once again, a bit like clamping altogether, but if some consideration is given in the design, we can make clamping arrangements for stair treads work. And I've also seen a similar arrangement done on a balustrade where we've used an FRP mesh for balustrade. If we add some small little flat bar tabs or a piece of angle or something like that on top of our ledger angle, or we contain the tread on the inside, so inside a channel with the legs of the channel, then we're providing some longitudinal restraint. So if those fixings were to theoretically loosen, that tread's not free to slide off down the staircase, if that makes sense. If we take these little steps like this, then we can easily use a clamp arrangement and safely use a clamp arrangement for our stair treads. The other option is if we want to deal with issues around corrosion and dissimilar metals on stair treads, we also supply a full tread kit. So we have our FRP grating, and we have this ledger angle here made out of FRP, holes pre-drilled to the centers that you nominate, and then you can just bolt that in. We don't have any dissimilar metals issues with the ledger angle because we're FRP, and the structure won't interact with that negatively. We can use stainless or hot dip gal or any other sort of bolts we want to use to bolt through, depending on what our structure is. And then we can just screw or bolt the FRP grating to that FRP angle. No corrosion issues induced in that angle because we're obviously not concerned about a coating as far as FRP goes. So that's another option to resolve that. That's the end of our session. Sorry, we're 5 minutes over time. Appreciate everyone joining. It's 1:50 p.m. here in New South Wales, where I am today. We'll stay on for a minute or two. If anyone's got any questions, feel free to open the Q&A window and put those in, and we'll try and answer them if we can. Otherwise, appreciate your support through the year, and we look forward to seeing you again next year. I think Mark just raised your hand. If you could just type your question into the window, Mark, instead, I'm not sure this meeting setup allows me to allow you to speak and listen. Doesn't seem to be many questions coming through. A few people started to drop off the meeting. So once again, appreciate you joining. This is the last webinar for this year. Michael's got a question about solar mesh panels through GAL PFC. Yes, I can. If you just send an email to hello@treadwellgroup.com.au, Michael, that'll get forwarded through to me and I'll be able to respond back and we'll go from there. But yeah, certainly happy to help with that. Sounds like an interesting question. Thanks once again, everyone, for joining. Have a good end of year break and a good Christmas and a good New Year. And we'll see you again in February. Um, in the meantime, anything you need, give us a yell. We'll have a few staff members taking a break over the holiday period, but we won't be closed. We'll have skeleton staff on at all times. So if you need anything dispatched, we'll be able to do that. If you need any queries, we'll be able to address those for you. Um, we'll wind back the crew a bit, but we won't stop. So we'll be open throughout that period. Question from Ian. Yeah, so regarding the stair tread fixing, if we're using an FRP ledger angle, you can use whatever fixings you like. GAL is absolutely fine. GAL's fine with FRP. Stainless is fine with FRP. I've seen titanium fixings, not cheap, but can be done. Some exotic stainlesses, 2205, 2507, etc. FRP ledger angles, you can use whatever fixing is most appropriate for the whatever material the string is made out of. I don't know if that makes sense. Looks like that's the end of our questions. I know, one more. Yep. Thanks, Ian. Yeah, Gal bolts and Gal steel, that's fine. No problem as far as the FRP is concerned. Thanks, everyone, for joining us. Appreciate your support during the year, and we'll see you in February for another Tech Talk Tuesday. In the meantime, as I said, hello@treadwellgroup.com.au. If there's any questions or notes, happy to have a chat, happy to help however we can, whether that's a quick site walk, whether that's an in-person discussion, whether that's setting up a Zoom or Teams meeting, whatever it takes, happy to help however we can. We'll wrap it up now. Appreciate you all joining. Thanks for your support. Have a good end of the year. Hope you all get a bit of a break, and we'll see you in 2026. Cheers.